Hello everyone, this is Ankit Shivare. We are going to have three problem sessions for module 1. This is our first problem session, so we are going to solve two problems in this problem session 1. The first problem is you have to prove that f of E is symmetrical to EF. I think this problem will also make you understand the theoretical concept. So let us prove it. So what is Fe? Fe is given by 1 by 1 plus exponential E minus EF by. So now you put different values of E and assume one single value of EF, and in that way you can prove that f of E plus delta E is equal to 1 minus f of E minus delta E. So in this way you can prove that Fe is symmetrical to. So for this case let us assume that EF is nothing but one electron volt. Let us see. Okay. Now put different values of E for this case. Okay. So let us say E is 1 electron volt and symmetrical about EF. Okay. So this is 1 electron volt. So let us say that E is now 0.98 electron volt and just the same symmetricality maintained 1.02 electron volt. Suppose 1.05 electron volt, so this will be 0.95 electron volt, and suppose this is 1.25 electron volt, and let us say this is 0.75 electron volt. In this way, it is symmetrical with respect to 1 electron volt. Now let us see the different values of E minus EF by kT. Okay, so E minus EF whole divided by kT for these different values will be, so here E is smaller compared to EF, so this is point, when you calculate it, 0.96 9.6525, you will get this value. Okay, so you put substitute EF is equal to 1 electron volt, kT is equal to 0.026 electron volt at equal to the value. Okay, so you substitute this, you will get this value. So only 0.95 for E is equal to 0.95 electron volt. When you substitute, so you will get minus 3.8610. For 0.98, you will get 0.7722. For 0.75 electron volt, the E minus EF by kT value will be minus 9.6525. For this value, for 0.95, the value is minus 1.9305. Similarly, for 0.98, the value is minus 0.7722. Similarly, when you put 1 electron volt, since you put 1 electron volt, so E minus EF is 0. So this is 1 by 1. So the probability is in that case simply 1. Okay. For 1.02, this value will come out to be plus 0.7722, or this it will come out to be plus 1.9305, and this value, so 1.25, this value will come out to be plus 9.6525. Okay. Now you substitute these values Fe, that is Fe is what? 1 by 1 plus exponential E minus EF by kT. When you substitute these values, so what you will get is, for this case, this is coming out to be 0.99994. For this value, it is coming out to be 0.87330. For this value, this will come out to be 0.98, 0.6899. Similarly, when you put here, for Fe is equal to 1, we know when E is equal to EF, this value probability will come out to be 0.5. And when you substitute here, you will get the same values, 0.68399, 0.87320, and 0.2. You can see the probability of finding an electron with distance EF, when each one 1.25 electron volt and EF is 1, it is more here. Okay. You can see the probability of finding an electron at energy level E is symmetrical with respect to EF. Okay. So this problem makes you understand the theoretical concept. Okay. So let us solve the second problem for this module. So now in this case we have been asked to assume that effective number of states in conduction band is equal to the effective number of states in the valence band. We have been given that energy band gap energy is 1.1 electron volt. Concentration of electrons is 10 to the power of 15 per centimeter cube. The difference between the edge of conduction band minus the edge of donor band is 0.2 electron volt. EC minus EF, the Fermi energy level, is 0.25 electron volt, and you have been asked to assume the temperature is 300 Kelvin. Now you have been asked to find what is concentration of holes, comma, what is NC and NB in terms of value. Okay, so these are the things that has been asked to do. So we have to figure out the answer for this case. Okay. So let us use the formula that we know that n is given by NC exponential minus of EC minus EF whole divided by. Okay. So let us substitute this value. So what you get, 10 to the power 15 is equal to NC exponential minus, this is given to you 0.25, and since temperature is 300 Kelvin, so KT is 0.026 electron volt. So in this way you can get NC value is 1.56 into 10 to the power of 19 per centimeter cube. So this is the answer. Okay. Now you want to determine the concentration of holes. So therefore concentration of holes is given by Mg exponential minus EF minus EV divided by KT. Now to figure out what is EV value, we can solve the concentration of holes because NC is equal to NV. So let us draw the band gap. Okay. Suppose this is your EC, this is your EV. Difference between these two, that is EG, is 1.1 electron volt. Okay. Now concentration of electrons is given to you, that is 10 to the power of 15 per centimeter cube, and EV is given to you, so this is your EV, and the difference between these two is given to you to be 0.2 electron volts. So EF and difference between EC and EF is 0.25 electron volt. So this is your EF, 0.25 electron volt. Okay. So this is the case. So now you need to determine this difference. So since we assume this is 1.1, this is 0.25, so we can 1.1 minus 0.25 will be this difference. So this is 1.1 minus 0.25, which is coming out to be 0.85 electron volt. To substitute it here, so P will be nothing but 1.52 into 10 to the power of 19 into exponential minus 0.85 by 0.06. So the concentration of holes will come out to be 8.71 into 10 to the power of 4 centimeter cube. Now remember that this is donor ion, okay, and this is very close to conduction band. So at room temperature, the electrons will move from the donor energy state to the conduction band state, and the electrons will be available for conduction. Okay, I think these are the two problems for this module, and in the further modules we will be going to solve more number of problems. Thank you for watching.